particle P and Q, where their weight is both mkg. We can see that theta is given as such. The length is also specified 0.75, 3.25, and they are saying AB is smooth, so no friction over here, and this one is rough with mu value is equals to 0.25. Particle P is released from rest at A, and the same instant Q is also released from rest at B. Verify that particle P reaches B 0.5 second after it is released with speed 3. So I have to verify both of it. So as usual, what are we going to do? We're going to list our SWOT. Your S is 0.75, your U is 0. You need to find the V and also the time. That means I need the A value. So how can I find the A value? I'm going to use net force equals to MA. The only force that the A has now, the particle P has now is component of weight. So what is that? mg sine theta. Can you see the other component of weight is here with mg cos theta. So mg sine theta it's equals to ma. Cut that mass and you will get your A value, which is 6 meter per second squared. Now what we can do, we can go and start by doing the T first. So S is equal to ut plus half at squared. So you input everything. 3t squared, therefore your t should be 0.5 second. Since I have the t value, I can find the v using u plus at. Initial is 0, acceleration is 6, time is half. It took half second to travel 0.75 meter, therefore the final speed at B is 3 meter per second. The second part of the question says we need to find the time it takes from the instant the two particles are released until they collide. So what is exactly happening? So you have to think when the particle P has traveled to B, it means this is the position of the P prime now. Don't you think the Q must have also traveled to some distance? What would that be? So this is the position of the Q prime. I want to find that. So let's go and write SWOT for our Q. So initial speed is 0. You don't know how much it has traveled, but you know the time taken is going to be 0.5 second. Why? Because the P has taken 0.5 second to travel. So I want to know in that 0.5 second how much the Q must have traveled. Correct? So let's find the A value. You have to be careful with this A because the surface BC is rough. So when you are doing the net force equal to MA along with the component of weight, which is same because their mass is the same, you need to minus your friction. Okay, the friction is in the opposite direction. So what is going to be my friction? It's mu times by r. What is your component of weight? mg cos theta equals to ma. I'm writing in a very small space. I think you should be able to do it. So when I do this, what will I get? I'm going to get a 6 here minus 1 over 4. Okay, what is 10 times by cos theta? How do you find the cos theta? Sin theta is equal to 0.6. If you want to find the cos theta, you can do two way. The easy one is substituting the theta directly. What is theta? Sine inverse 0.6. You put this in the calculator, you will get an answer. Another one is by using your regular ratios. What is 0.6? It's actually 6 over 10. So this is my opposite and this is my hypotenuse. Therefore, I want to find the cos. Cos is what? Adjacent over hypotenuse. In that case, what is your adjacent? 8 out of 10, which is 0.8. You will get the same thing. So let's put 0.8 here and solve it. Therefore, my answer is going to be 6 minus by 2. So you get a 4 meter per second square. Can you see the acceleration value when it is rough? It was how much? What did we get? We got a 6 here. But now the same mass, same condition, but the acceleration has reduced because of the friction being involved. Okay, now let's go back here and we write our A value. A is 4 meter per second square. Do you think you can find the V value and the S value? Same technique. Okay, let's use the same thing and see ut plus half at squared 0 plus 2t squared. So what will I get for my s value now? 0.5 squared times by 2. Okay, so it has traveled 0.5 meter. So this part here is 0.5 meter, and what is the time taken? 0.5 second. Okay, now I want to know what is the speed of that q when it is traveled for 0.5 second. U is 0, a value is 4, and the time taken is 0.5. So you are going to get 2 meter per second. So let's write all these answers. My s value here is 0.5 meter. And my v value is 2 meter per second. Okay, now what happens? To make my life easy, I am going to do a new path. So where is that path? I just want to focus from here. I want to focus from p prime and q prime, and then there's going to be a place where they are going to collide, correct? Let's say they are going to collide here. So this is my new path now. Okay, new path. So what I'm going to do, I don't know what is this. During the collision, I know they're going to meet at the same place, right? So what can I write? Let's say if you don't know this, let's put it at x. So what is the distance traveled by the sp prime? So let's write here. Can I say the distance traveled by the sp prime, it's equals to 0.5 meter plus the x. So what is that x? That is the distance being traveled by the q. So I'm just going to put as q prime. Now it becomes easy because I have all the information. So let's go and write for as q prime. Because I have all the information here. Okay, I'm just going to substitute ut. What is your u value now? It's 2. 2t plus half 4t squared. And what about your sp prime? Did you get all the information for sp prime just now? You look at this. So the part A will actually help you. What is the final speed when it was at B? 3, right? Okay, so let's do it. What was the final speed when it was at B? It's 3. Final speed was 3. So ut 3t plus half. What will my acceleration be? Can you give a guess? They have the same mass. The p prime or the particle p is now going to travel on this path BC, which is rough. Because it is rough, that acceleration is going to be similar to your q. So you're going to use the 4. Okay, 4t squared. By now you would have realized, because the acceleration is same, it is following the gravity only. So I can just delete my half at squared, which is 2t squared. It's getting cancelled. Therefore, the t value, it's going to be 0.5 second. It means for them to come from Q to this collision, how long are you going to take? You are going to take total time of 1. That is, I can see 5 seconds plus by the 5 seconds, you get a 1. Okay, this part C. The two particles coalesce when they collide. It means particle P and Q will merge. The coefficient of friction between the combined particle and the plane is still 0.25. Okay. Find the time that it takes from the instant that the particle collide until the combined particle reaches C. So let's start with the first idea. Because they use the word coalesce, so you know you're going to use conservation of momentum. So when I do this, what will you write? So the m1 v1 plus m2 v2 is equal to coalesce means you merge the particle and you get a speed over here. So let's say this is for P and this is for the Q. What do I know? I know their mass is the same. So m, I'm not sure about the speed. M, I'm not sure about the speed. This is actually 2m and we are having a v over there. Next step, So how do I find this V value for the P? So let's write our SWOT. Okay. Just now what did we do? We have our P here, correct? The P prime. And then this was my Q prime. And then I wrote that this is going to be my X. And you figure out that this is 0.5 plus that extra X that you have there. Okay. Now, let's see. What is exactly happening at P prime? Just now we calculated the U is 3 and the A value is 4. How about U prime? My U is equals to 2 and my A value is equals to 4. This is from the part A and B. We are using this information. Okay, next, what is happening? So, I am going to find the distance it has traveled. So, what did we write for as P prime? It was 0.5 plus by X, correct? So, what did you do? This is as Q prime. Okay, I'm just repeating the same thing again. So, UT, you got a 2 and your T value was just now 0.5 plus half A T squared. So when we solve this, what are we getting? So 0.5 plus by 1 to 0.5 squared. So can you see you actually getting a 2 meter. So if the distance traveled by the P prime is 2, I know that the distance traveled by Q prime is going to be 1.5 meter. So we can do for both of them now. Let's say I'm finding for the Q now. I'm going to write the SWOT again. So this is 1.5 and that is a 2. So what is the speed that they are traveling before they collide here? Isn't it 3? And how about this? It was a 2. Okay, we are not sure at what speed it is colliding, so leave it. And how about the A value? The surface is rough, they already told us, and it's just going to be a 4. And the time taken for the second part of the journey is 0.5. Do you think you can figure out your U value now? I mean your speed. V is equal to U plus AT. So 3 plus 4, 0.5, which will give me 5 meter per second. So before the collision, when they are coming here, the speed of the P, it's actually 5. So let's park it there. Now how about the speed of the Q? 2 plus 4, 0.5. So I'm going to get a 4. So let's park it over here, 4. Now, do you think you can find the speed at which they will have when the particle coalesce? It means merge together. Okay, let's solve. I cut the M here, cut the M here, cut the M here. So 9 is equals to 2V. So when they coalesce, the speed of the particle will be 4.5. Okay, what's next? What do I exactly want? The question is asking me to find the time it takes from the instant the particles collide until the combined particle reaches the C. So where is this C? C in the diagram, it's slightly at the bottom. Okay, let's go to the diagram. Okay, C is over here, correct? You can see the C is here, okay? So what is the balance distance you have? So the collision actually happening here, and you know the the P prime has covered 2 meter here. So what is the balance length that we have here? 3 minus 3.25 minus the 2. So let's look at this part. Reaches the C. So S is equal to UT plus half AT squared. So how do we do this? 3.25 minus the 2. What is the speed at the moment when they merge? 4.5. T half. The acceleration is still the same. It won't change even when you merge. Let's say if you are not so sure about this, you can try it again. What do you have? The two particles are together. So their mass is now 2m. So 2m g sine theta minus, you're going to have a friction 0.25 r. What is the r? 2m g cos theta equals to 2m a. See, you're going to get the same thing because I cut the 2m. Everything is the same. 2m. You cut. So what do you end up? Tan sine theta minus 1 over 4 tan cos theta. So the a value won't change. You get a 6 here. You get a 2 here. So it's just a 4. So when we solve this, what do we get? 1.25 equals to 4.5t plus 2t squared. You input this into the calculator, you will get 0.25 second.